Hello everyone. I hope you guys are fine. Today we are going to solve LeetCode question number 19. Remove the NF node from end of the list. So we have given a linked list. We have given the head of the linked list, and we have to remove the NF node from the end of the list. Like in this example, we can see we have given a linked list 1, 2, 3, 4, 5, and we have to remove n equal to 2 means second last element from the linked list. Like we have this 1, 2, 3, 4, 5. Then what will be the second last? 5 is the first last, 4 is the second last. So we have to remove 4. So what we have to do? We have to remove 4 and we have to save 3 next is equals to 5. So this is our task. We have to do it. And some edge cases are like that. If we have one node and we have to return 1, then we have to return empty means we have to return null values. Like where we have two values, we have to return the first value means we have to return the two, remove the two. We will remove two and return one. So this is that we have given number of node is SZ less than or equal to 30 and greater than or equal to 1 node dot value lies between 0 to 100. So it is saying could you do this in one pass? Like what other approaches, what first approach we had in our mind, like if we reverse this, means if we reverse this linked list, then it is same as that remove the nth node from the linked list from the first side. One from the start, remove the nth node. It will become easy. First we reverse it, then remove the second node, then again reverse it and return. So it will take uh, minimum two passes. So it is saying that could you do this in one pass? So let's see how can we do this in one pass. Like we have given this the first approach that come in our mind. Like we create uh, like how can we reach to this node? Means if we have to remove four, we have to reach to three. So how can we reach to three? Like if we start a pointer from here, like uh, we start a pointer from this, like we start pointer from this, like three, and another pointer to one. Then we move three one time, and this one time, then again one time, then one time. When it is the our last element, so we will like add this, we will remove this element. So let's see the code. You will get better understanding. Like I have created a dummy list, dummy node with value 0 and its next value is null. Then what I am doing? I am doing dummy dot next means the dummy element that we have created, its next value, we make it head. Means we create another node with value 0 and we add it to the head of the linked list. Then create two pointers that point to the dummy. Means the pointer point to before the head. So see this how beautifully we have solved this problem. Like both pointers are at dummy and we move our first pointer and plus one times. Means for value 2 we move our pointer three times. Means from dummy to 1, dummy to 2, sorry, dummy to 1, 1 to 2, and 2 to 3. Now our first pointer is at node 3 and our second pointer is at our dummy. Ah, first pointer is at node 3, second pointer is at dummy. So what we will do? After that, we will move each pointer one by one step until our first doesn't become null. So we will continue this process until first does not become null. So in first loop, first condition got true. We will move 3 to 4, and second pointer we will move dummy to 1. Then 4 to 5, then 1 to 2, then 5 to null, then 2 to 3. Now our first became null, so this will not satisfy this condition, so we will exit from the while loop. Now our second pointer is at the value where we have to remove this node. So we got to 3. So what we will do? We will do second dot next equal to means 3 dot next equal to 3 dot next dot next. After that, we will return dummy dot next. So why we use the dummy? Like this is for the edge cases. This is only its only purpose is for the edge cases. Like for one, if we do not add the dummy node, if we do not add the dummy node, then uh, here we will get the null exception. So we cannot go to the next of the null. Here we go to the null exception. This is dummy for the edge cases. So you can see how beautifully we have solved this problem. Like we set two pointer approach and we move pointer 1 plus 1 times so that we will move one by one, and the first pointer reaches the end. The second pointer is at that destination where we have to remove the element. So beautifully we solve this problem. So this is only a single pass approach. You can see we iterate a loop for the only one time. So if we submit it, when we submit it, it's 100% 0 ms. If we see time complexity of this, so what is time complexity? Time complexity is big of n. We iterate only one time. And what is the space complexity? Space complexity of big O of 1. So one pass. Here we have solved this problem in two parts, but uh, in the question, in follow-up question, it's asked in the one pass. So first you can solve this problem by two parts. I have solved this problem by two parts. Mainly that problem also consists a dummy node. We create a dummy node. We find the length. Then we find the position. Means what position we have to remove length. What is the length? Minus n means we find the what is the position if we remove from the first. What it will be the length minus n. So we find the position and we remove from the first one. So this is two-part solution because we iterate the list to find the length of the list. Then again we remove the element. So it is two-part solution. After solving this two, first this came to your mind. After solving this two-part solution, we have to optimize it for one pass. We have given this question, that follow-up question. Could you do this in one pass? So we will optimize this and do this one pass. So that's it. This is for the today's question. Thank you for watching.